Hey, this video is about the apportionment lab, which is your first of 2 labs this summer in this course. So the lab assignments are meant to give you a chance to show your understanding of some of the concepts that are covered in the course in a non-testing environment. So those of you who may not test well might appreciate the opportunity to do a lab to show your understanding, where it's not a timed, stressful situation where you can take your time, complete the lab, and then submit your final project. So you'll find this in week 2. This is one of the last things you'll do this week, so you should have already finished all of your homework in My Math Lab, watching these videos to help you understand the processes. So here's a lesson on 12C, so it's the apportionment in the early years, and here's a lesson, the second lesson, which is apportionment in the later years. And then you'll complete the homework that goes along with that in My Math Lab. So once you feel like you have a really good understanding of the processes of apportionment, what you'll want to do is click on this workbook to see what you have to do. Once you're finished, you'll submit your finished product in the Turnitin assignment link. So let me go to the workbook next. So in the workbook, you will see several worksheets down here. So you'll have instructions. This lets you know that it's a 2-part lab where you'll complete the worksheets and then you'll reflect on what you've done. And the worksheets are down here at the bottom. So we have the workbook instructions. This is a step-by-step guide including formulas that you'll want to include in your worksheet. So the workbook is all about doing the work using formulas. You're not going to do any work outside of Excel. You don't even need a calculator to do this. If you type in the formulas correctly, then Excel is going to do all the calculations for you. So hopefully you'll really appreciate what Excel can do after you complete this worksheet, because you won't have to go back and divide and all that stuff that sometimes takes a long time. Notice that we do have an absolute cell reference in this lab, so you should have learned about that in workbook 2. I did make a comment when I was grading workbook 2 that some of you might want to review those lessons because you use that here in the apportionment lab. So make sure that as you're completing these worksheets, you're following this step-by-step guide and you're using the formulas that they give you. All right, so you'll complete Hamilton's worksheet. Remember, Hamilton's is the one that ranks based on the fractional part of the quota. One of the hints I give in the instructions is that you may want to sort this worksheet from largest to smallest so you can see the biggest fractional parts, because that's how you award the extra seats. So the only word of warning is that if you do sort it, then you may want to resort it based on alphabetical order before you write a reflection. And I'll talk about that in just a minute. So you're not done with any of the worksheets until you have apportioned. Your final seats total here should be 210, because in the instructions it tells you we're apportioning 210 representatives. So then in Jefferson's method, that Jefferson, Webster, and Huntington-Hill, or Hill-Huntington, depending on which book you use, all 3 of these, the last 3, besides Hamilton, are adjusted divisor methods. So you'll set up this by following those instructions, and when you first come to apportion, you won't have 210 seats, not in Jefferson's method. It will be less than that. So you'll want to adjust this divisor by just typing in a number. So this is the only time you're not really entering a formula. So remember that if you have not apportioned enough seats, if this number is too small, then you want your standard divisor to go down so that this number will go up. All right, so keep that in mind as you're playing with this worksheet. So once you get it to exactly 210, you're done with Jefferson. Then you'll go to Webster. Now Webster's rounds according to the rules of math. So in the instructions, I give you the formula to use that. So you're going to use the round function. And then Webster's, you may or may not get 210 on your first attempt. If you do, you're done. If you don't, you'll need to adjust the divisor. And remember, if it's not enough, this needs to go down so that the final seats will go up. If the final seats is too much, you'll need to go up so that that will go down. And then lastly, you have Huntington Hill. Now the geometric mean and the rounded quota for these are very complicated formulas, so make sure you refer back, and under Huntington Hill or Hill-Huntington, here are the formulas that you'll use for those. So you can just copy and paste those formulas in because the syntax has to be exactly right. All right, so once you're done with all those, what you'll do, so you have 210 on all 4 worksheets, then you'll want to write a reflection. Now the reflection needs to be between 150 and 250 words, and I do not want you to recap the processes. I don't even want you to talk about the processes at all. What I want you to talk about are the results. So like I was saying, the best way to compare the 4 different workbooks or worksheets is to go to Hamilton. If you have sorted it based on the fractional part, you'll want to resort it in alphabetical order so that all of your worksheets have the states in the same order. And what you want to do is take Jefferson, Webster, and Huntington Hill and copy those final results. So I put Jefferson's final results in column I put Webster's in column J, and I put Hill-Huntington in column K. That way I could look across and see that maybe Connecticut had 5 seats, but Jefferson had 4, and Webster had 5, and Huntington Hill had 4. So in my reflection, I could talk about the differences in the different methods to how many seats were apportioned in each state. That's what I want you to focus on, not the processes for each method. So I did point you to some guiding questions that you could talk about in your reflection, and I want you to be very specific as you discuss these and cite examples. So I just gave an example where I may have seen a difference between the different methods in Virginia. So that's the kind of stuff I'm looking for in the reflection. So as you are comparing the final apportionment, discuss any differences or similarities you may see. Are there any differences in the allotment for the states using Hamilton's method versus Jefferson's, Webster's, or Hill-Huntington? If so, what are they? And be specific. Name the state and what the difference is. Does one method seem to favor larger states or smaller states based on this results? If so, explain how by giving specific examples. Does any method violate the quota criterion? And if you're not sure what I'm talking about, you may not have finished your homework because your homework talks about the quota criterion. But if you need to review that, that's found in 12C of your textbook. And what the quota criterion says is that each state's final allotment has to be their original standard quota, either rounded up or rounded down. So if I had a standard quota of 3.2, the final allotment should either be 3 or 4. If it's anything less than that or anything greater than that, that is a violation of the quota criterion. So if you see a violation, explain what it is, and if you don't, explain why you don't see one. And in your explanation, what I'm looking for is, do you really understand what the quota criterion says? So you need to state that in your explanation. And then if you see any other concepts from your textbook, you can talk about those in your reflection. You may even want to make a judgment about which method you feel is the best method, but I want to know why. So support your judgment with reasons why you feel this way. So let me make one other word of warning. As you're looking for a violation of the quota criterion, the only workbook that you're for sure to have the original standard quota is Hamilton's. Because on Hamilton's, you never have to adjust the divisor. So the quotas here should be the original standard quotas. So when you're looking for a violation of the quota criterion, that's another reason to copy all of the other ones to this worksheet so that you can see if any of these methods have something different than their original standard quota rounded up or down. All right, I hope that makes sense. I've taken enough of your time. If you have any questions, please let me know. Good luck as you complete the workbook. It's due at midnight tonight, not 3 p.m. It originally said 3. I'm not sure why, but I have fixed that now. So good luck. Let me know if you have any questions.